Hello everyone, this is a class of ECE341, the probability and the random process. Welcome. ECE341. It's the 5th week. It's for Wednesday's class. Right. Okay, we keep working on the random variables. So last time we introduced the concept of a random variable. That it will be a variable related with a random experiment, and for different result of the random experiment or different event of the random experiment, we can have some values according to that random variable, right? Random variable. So we can consider a random variable x, and then we define the two functions. We have the functions, the probability mass function. Usually we denote it as probability. The P means probability of this random variable is x, right? And it is defined as probability of capital X equal to lowercase x. Okay. The x is a value. You can use different value. You put different value, then this event is different, right? And you have different probability. And we also have CDF. It's a cumulative distribution function, cumulative probability distribution function. And this is usually denoted as capital F, capital X of x, which is also a probability. Here is a capital X smaller than or equal to x. Okay, so we have two functions. Now we study some examples related, and we will focus on the relation between these two functions. And we will also consider how to calculate the probability based on these two functions. Consider an example. Suppose a random variable x has PMF, probability mass function, like this one. Px of x will equal to 1/3 if x equal to 0, positive, or negative 1, and 0 otherwise. For any other x is 0. If x is 0 or 1 or negative 1, the value is this. So this means if here's a kind of experiment, and then you measure some value from that experiment, then the possible value are 0, 1, and negative 1. And each one has same probability, 1/3, right? Okay, now we can consider the first one. I want to find CDF. Second one, I want to find the probability of x larger than or equal to 0. What it is. Okay, now let's I can do the third one. Actually, this should be the first one. I write this first. So okay, this is the last one. Draw graph for both Px of x and Fx of x. We give the graph of them. Okay. Now we try to solve it. The first one, Fx of x. We want to find these. By definition, this is a probability of capital X smaller than x. Okay, then you can see what is this one, that means by this one we already have these. We know we have these. This is x. Its value will be -1, 0, and 1, and the probability will be 1/3, 1/3, 1/3. Right. So this is all the possible values of x. You can think this is sample space, but of course it's x usually coming from some sample space, some experiment. But that sample space might be depend. Maybe it is described by some words, right? Some words, some description, some statement. And here I just suppose x has these three numbers as its possible values, and each has probability 1/3. And for all the other value of x, right, as a variable, a real variable, x could be any value, like -10, +5, right? But for any other x, the probability is 0. Okay, so we have this. Now we can find this fx very easy. Then we have fx, capital X here should be, sorry, this should be capital X, this should be capital X. I put this capital X is the name of the random variable, and this lowercase x is a changing value. So this one will equal to, okay, by definition it is a probability. This is R. Oh, yeah, I'm confused. Sorry. This is a PR of x smaller than x. In this one, this is probability of capital X smaller than x. So you can see if x is a number smaller than 0, then P probability of capital X smaller than x is nothing. It's empty, right? Oh, not empty. Smaller than yeah, it's empty. It's here. It's -1. Smallest value is -1. If this one is smaller than -1, then we cannot have this as a result, because capital X, the smallest capital X, smallest value of capital X is -1, and this lowercase x is even smaller than -1. So this is an important possible, no possible, right? Important things, important event. So this is 0. And if x is a value between 0 and the -1, then the probability capital X is smaller than or equal to x. Actually, this is a probability of x equal to -1, right? So it is 1/3. And if now x is from 1 to, oh, this is 0. Sorry, 0 to negative, 0 to 1. 0 to 1. This is 0. Sorry, confused. This is 0. Yeah, -1 to 0. Then 0 to 1. This probability of this event, capital X is smaller than this x, then we can have x equal to 0 or -1. So I have two results, right? 2 results, and each is a probability 1/3. So it's a 2/3. Okay. And if x is larger than or equal to 1, then probability x smaller than x, there will be probability of capital X equal to 0, -1, or +1. Okay, so 3 of 1/3. That's 1. Okay, so now let's write the formula together. Write this function together. So f capital X of x, this will be, its value will be 0, 1/3, 2/3, or 1. So 0, 1/3, 2/3, or 1. In which case it's 0 if x is smaller than -1. And for 1/3, related with these, if -1 is smaller than x, x smaller than 0, and then x between 0 and 1, include 0, and finally if x is larger than and equal to, larger than or equal to 1. Okay, so this is a fx. And okay, then the second, we want to know the probability of x positive. Actually, we can have it here, right? Positive, non-negative, larger than or equal to 0. So it's this one plus this one. It's 1/2, right? It's 2/3. Probability of capital X larger than 0. It is a probability capital X equal to 0 or 1. So it's 2 of 1/3. It's 2/3. We can also write these. You see, we have two parts, right? Two parts. I need 2 of these. I can also write it as probability mass function of x at x equal to 0, and probability, the mass function, I use x equal to 1. Okay. It is still same thing. Yeah, I still get this value. Okay. And 3, okay, as I asked for, I want the graph of these two. So the first one is given, right? Px is given, has 1/3, 3 of 1/3, and all the others are 0. So the graph will be for P. So we have 1/3, 1/3, 1/3. Each is 1/3. Here's a, I start from -1, should be here. -1, 0, and 1. Like this. This is a mass function, probability mass function. We have these 3 non-zero value, and all the rest they're zeros. All the rest are zeros. Okay. And for the density function, not density, it's a CDF, the cumulative distribution function, CDF, which is a fx of x. Okay, it's 0, 1/3, 2/3, and 1. So it's 0, then 1/3, 2/3, and 1. Here's 1. This is 1/3, this is 2/3, and this is -1, 0, and 1. Right? Okay, and at this point, this will be solid. This is a circle. This is solid. This is a circle, empty circle, and this is solid. So the CDF looks like this. CDF looks like this. Yeah, this is like things. Usually we will have, almost not usually, all the time. The CDF will be a function in graph is a kind of a steer-like, right? Steer coming up, coming up, coming up. You start from 0, then coming up. After a while, it will reach 1, then keep 1 forever. No more than 1, because the largest probability is 1, right? This is probability. It is a probability, right? So its value at most equal to 1. The 100% is the largest one. So they have this, the largest one. So it will start from 0, then increase, steer likely, then finally reach 1. This is CDF. And for probability mass function, PMF, things like they will have some parts, some non-zero values related with those symbols with positive probability, and 0 anywhere else, because those values of x, it is kind of impossible to happen, right? Impossible to happen. Yeah. Okay, this is one example. Okay. Example. Okay, now to check another example. Example 2. Now we go through another way, right? This example, we know the PMF. We start from the PMF, and then we try to find the CDF, right? Now we go use another direction. Suppose a random variable x has CDF like this. Fx of x equal to, I say 0, 1/5, 1/4, 1/3, and 1. Maybe too small, and these are 2/4. Okay, 2/3. 2/3. This is 1/4. Yeah. Okay. Suppose this is fx, and here, if x smaller than 0, and this if x is a value between 0 and 1, and this is if x is between 0 to 3, and this one is if between 3 and 5, and here if x larger than or equal to 5. Okay, suppose we have this one. Then we want to find what is a what is a mass function, probability mass function. So, we want to find probability mass function. Secondly, we want to find the probability of x larger than or equal to 3. And third one, I want to find the probability. Okay, I use a conditional probability. I still consider the probability x larger than or equal to 3 under the condition 1 smaller than capital X, smaller than 4, smaller than, okay, just larger than 1. Okay, I just use x larger than 1 as a condition. We want to find the probability of larger than 3. This conditional probability. Okay, we want to find these 3. We have 3 questions, and of course, and I want to draw graph of fx, the CDF, and the probability mass function. I want to draw the graph of these 2 functions. Okay, now how to do it? Here we have fx, right? Fx. Then what can we do? We can think like that. Fx, you can see they have different value, right? So every time when the value changes with that point, you see here, when x is 0, the value is changing, right? Value from 0 to 1/5. The function has value between jump from 0 to 1/5. And when x equal to 1, you see 1 here or here, the value jump from 1/5 to 1/4. And similar, when x has value 3, the value jumps from 1/4 to 2/3. Right? So every time you have a kind of jump, and here is also a jump. That jump gives us the information about the probability. So this one, it is a probability of x smaller than or equal to x. So and fx x equal to probability. Here I minus some dirt, minus a dirt, equal to x smaller than x minus dirt. Okay. So these two, the difference difference is probability of x equal to x. You get it? The idea is just like this. You see? In the first one, the event contain x, contain this lowercase x. Capital X will be a value smaller than or equal to x. So this event contain x equal to x as a part of it. And the second event, x is smaller than or equal to x minus a third. So the second event do not contain this x, right? Do not contain it. So first one contain it, and second one do not contain it. Then the difference is just this one. So we can have probability of x equal to x, or equal to the probability x is smaller than x minus the probability of x smaller than equal to x minus third for third positive. Third should be positive. Usually it's a small number. I write in this way. I write in this way. This is small enough. Make sense? Yeah. And in graph, okay, so let me give the graph firstly. Yeah, I have space here. The graph of fxx f 0, 1, 5th, 1, 4th, 2/3, and 1. So totally we have 5 numbers. 5 values for this f, capital F. And in the variable x, the change happen at 0, 1, 3, and 5. Okay, so let me put it here. We can see both, right? So at 0, 1, 3, 5, this is for x. At this 4 point, the value is changing. The value run from 0, then jump up to 1/5. 1/5 is 0.2, right? And then keep these and jump from here to this will be 1/4, which is a 0.25, right? 25. And then here's 1. Here's a 1/4. Here's another 1/4. So you do summation, right? Yeah, 1/4, not summation. And when go to 3, at 3 I have a jump that's 2/3. So here will be 2/3, which is a 0.667, right? And then 2/3, then 1. So this is a graph of the CDF. This is CDF. And as we discussed here, you check the difference between these two, you have this probability. So at every point, you check the difference between this one and this one. This is a jump, right? You can have the probability here. So where's the probability mass function? Doesn't work. Okay, probability mass function x or equal to the just probability of capital X equal to x, right? Equal to, I can have several values. When the x equal to 0, 1, 2, 1, 3, 5, we can have, if x is 0, here the jump is 1/5. Right? And when x is 1, this jump is 1/4 minus 1/5. Right? Here's 1/4 and minus this part. So things like this one minus this one. Right? This one minus this one. and when x is 3, there will be 2/3 minus 1/4. You get it? Here's a 2/3. This point is 2/3, and this point is 1/4. 2/3 minus 1/4, we get this part. So how much it jump up, right? So it is this one. All right, similar, last one. When x equal to 5, here we have another jump. This should be 1. So it is 1 minus 2/3. So we have the mass function will look like this. Okay, these 4 values give the value at the when they have jump, right? When the CDF has jump here. Then for the other rest, it will be 0. Other values of x. For any other values of x, the mass function probability mass function is 0. All right, then let me rewrite it. Rewrite it. This is a 1/5, and this one is okay. I write this as 0.2, and this is 1.1. This minus 1/5 equal to 0.25 minus 0.2 is 0.05, right? So this one. Then this one is 2/3 is 666, right? Minus 0.25. So this is 416. 416 forever. So we can put the 6 here, 6 dot here, or just 6 with 2 dots is fine. Okay, this is this one. This is this one, and this one is 1 minus 2/3. That'll be 1/3. And the last one, no last one. Then other values, 0. Okay, so others. This one is x equal to 5. This is x equal to 3, and x equal to 1, x equal to 0. Okay, so the mass function looks like this. Probability mass function is just like this one. And then actually this mass function, you can think it is a list of the probabilities. When x has value 0, 1, 3, 5, its probability are 0.2, 0.05, 0.4, 1666, and 0.333. All of them are 3. Right? Yeah. And here we can double check whether it's correct. We do the summation of all of these. This one should be 9, but you have all the 9s will be going up, so it's a 0 and put 1 here. 6, 3 is 9, and you have 1 coming up, so this is a plus 1. 9 plus 1 you get 0, so coming up. Then 5, 1, 3 is 9. 9 and 1 coming out from previous step, so here's a 9 plus 1, it is also 6. Also 0 and 1 value coming up. And then 4 and 3 and 1, and here's 2. 4, 3, 2. 4, 3, 2 is 9, and 1 coming up is 9. So okay, summation is 1 is correct. Yeah, I'm just checking. This is a mass function, and I also need the graph, right? As a problem, I need a graph. I already have the CDF's graph. Right? I already have the CDF's graph. Now I want the graph of the mass function. Mass function, it is just you put the value x. This is x equal to 0, 1, 3, 5. Here value is a 0.2, then point small value 0.05 and 0.416 and so on. And the last one is when the I think I missed something. Oh, sorry, 0.5 is here. X is y is okay. 0, 1, 3, 5, and here's a 0.2, and this one, when x is 1, it's 0.05. Alright, this time is good. Then when x is 3, it is a 4 dot something, 0.4167, and here will be 0.4. Let me see. When this is a 5 is a so 3. Sorry, it's a 0.333. Yeah, a lot of 3. This is x. This is CDF. This is mass function. Mass function. Px of x. Looks like this. So we have two functions with two graphs. This one is a CDF. This is a PMF. PMF contains several parts, right? Several bars. The peak value are the probability of that event symbol. And this one, it's a stair-like function, right? It looks like stairs. And where the jump happen, they are just in the same point with this 0, 1, 3, 5. Here's 0, 1, 3, 5. When x equal to one of these 4 values, the fx of x will jump up, right? Jump up. And how many it jump? It is just same as this. Like here's the jump by 0.05. Here's 0.05. Here's the jump by 0.2. Then here's a 0.2. Yeah. And like this jump is 0.333. Then here's a 0.333. Yeah. Okay, this is the first one. And then we want the second problem. We want to find the probability of x larger than 3. Second one, we want to find the probability of x larger than or equal to 3. For this one, actually now we know. Yeah, we have both graphs. Right? We have CDF and PMF. In both cases, we know the probability will occur at 0, 1, 3, 5. 0, 1, 3, 5. So that means you can think the sample space is 0, 1, 3, 5. And now we want x larger than 3. So among all of these, which are the case larger than 3? We have these two. So it is a probability of x equal to 3 or 5. Right? 3 or 5. And if it is 3, see, 3, the probability is 0.416 something. 4167, right? Something like that. And if it is 5, that will be 0.333. Okay, we do a summation. The 0.43 is 7, 1, 3 is 4, but I think we have 1 coming up. 1, 3 or 4, and plus 1 coming up, there will be 5. Alright, so we can have the probability of capital X larger than 3 is this one. Alright, then we have the last question. We want to find the probability x larger than 3 under the condition x is value larger than 1. We want this. So what is this? Oh, remember the conditional probability? Actually, we just do the similar calculation. It's conditional probability. This will be the probability of x larger than 3 intersection with x larger than 1. This is numerator. And denominator is the condition, probability of the condition. That's it. That's it. Okay, we need to plug in x larger than 1, larger than or equal to 1. That is a probability of 1, 3, or 5, right? 1, 3, or 5. The x equal to 1, 3, or 5. And here the intersection of these two is larger than 3 and larger than 1. Larger than 3 and larger than 1. Larger than 3 and larger than 1. So actually this is as same as probability of x larger than just 3, which is probability of x equal to 3 or x equal to 5. Any one of it will be fine. Okay, so now I put the probability. Numerator is 3 and 5. We check the mass function here. 3 and 5. Probability of 3 and 5. This is a numerator. Denominator is 1, 3, 5. 1, 3, 5. So the probability is summation of these three. 0.05 plus 0.4167 plus 0.333. Alright. Yes. And the denominator is larger than 3, so 3 and 5. 3 and 5 is 0.4167 plus 0.3333. So this gives us the numerator is 0.75, right? And the denominator, we have these plus 0.5. So just this one plus this, it's 0.8. Okay, so this is the probability. If we want to do a calculation, what it is? 75 over 80 over 80, so and remove this 0.72. I have 30. Then 3, 8, 24. I have 24. I have 6, and this will be 7, 5. So this is a 0.9375. Alright. So this is a conditional probability. Now both are the probability of x larger than 3. But the first case, no any other conditions. And the second, we already know x is larger than 1. So we have a condition. And with this condition, the probability is a little bit larger. Oh, not a little bit, larger a lot. Right? So 93. This is 7% 75. This is percentage 93. Alright. Okay. Actually, we can also calculate the probability by fx. So this one, or this one. Probability of x larger than 3 or equal to 1 minus probability x smaller than 3. Right? Smaller than 3. Smaller than 3, in this case, it is just probability x smaller than or equal to 1. It cannot be 3. Our values will be at 0, 1, 3, and 5. So smaller than 3, then include 1. So I can use just here, I use 1, right? Compare here, this also works. And 1 minus, what it is? This is fx of 1. And fx of 1 is given. It is 1/4. So this is 1/4. 1 minus 1/4, that is 3/4. That is 0.75. Yeah, same value, see? Same value. So you can also do the calculation by fx. Alright. I work like this way is before we do the calculation, we start from the fx, we do some work, and then we get these two graphs. I get these numbers of values. Okay? These values are the probabilities. I get these two, and then I do calculation based on these two. This way, we do not need to find these two. Just you plug in what is fx, we can have the answer. So this is a way, like if you only want to know the probability, you can calculate directly. You don't need to find what is CDF. What is you do not need to find what is a PMF. You can just use the CDF, calculate directly. And this one is similar. This is a 1 minus smaller than or equal to 0. Smaller than or equal to 0. So minus fx of 0. And the numerator is 1 minus fx smaller than 3. So this is 1 minus 0.2. Okay. This is 0.2. And the numerator is 1 minus fx3 is here. That is 2/3 minus 2/3, which gives us 0.8 in denominator. Numerator is 1/3. So what it is? It is this one. 1 minus this. This is 1 minus. I confused by myself. What it is? Larger than 3. So it's 1 minus smaller than 3, or 1/4. I'm sorry. Right? Larger than 3. So it's 1 minus. Here should be smaller than, but cannot equal to 3. Cannot equal to 3, so here should be 1. I'm sorry. Here should be 1. 1, this is 1/4. 1/4. So, yeah, 1/4. So 1 minus 1/4 will be 3/4. 3/4, it is 0.75 over 0.8. Oh, same thing. Yeah, same thing. Alright. So, yeah, this is also a way. This is also a method to calculate. We use the fx. We use fx to do the calculation. And generally, we can have this. Probability of capital X smaller than or equal to A, and larger than. I have several. I write this one. Probability of X smaller than or equal to A. This one, it is just f or x of A. And the probability of X larger than equal to A, there will be 1 minus fx A something smaller than A minus a third. A minus a third. Third is small number. Small number, right? So we have this. And the probability, if we have an interval, it's A smaller than X, smaller than equal to B. This will be fx of B minus fx of A. So in general, you can do calculation like this. But here you have to pay attention on the equals. Here's larger than, and have equal. Then this side you did minus, right? Here's equal. Here's equal. Here's no equal. Yeah. You can also think about, other than these three, you can think like this one. What it is? Oh, My pen doesn't work. This one, okay. What is this? Probability x larger than a. What it is? And the probability of a smaller than or equal x large smaller than b no equal. What it is? Yeah, you can after class you can think. Can we give some formulas? Can we do the calculation based on fx to find out? Of course, you use the mass function will be fine. Mass function, basically mass function, it is just the list of the probabilities. The mass function, right? The mass function like here. This is the mass function, right? This is the mass function. Like this example, I have a mass function. It looks like this. It is just a list of the probability. X equal to 0, it is probably 0.2. X is 1, the probability is 0.05, something like that. Right? Yeah, it's just a list of the values. And the CDF a little bit complex. CDF is a kind of cumulative, right? Cumulative. It's a summation of some terms. So we have this, and also yeah, I can write this. The cumulated this x equal to summation of px of x. I say this is y for or y smaller than and equal to x. So we have this. This one is a summation of these for those y smaller than x. Right. Yeah. Okay, that's all for today. See you next time.